All right, now we are going to do chapter 2.3 from Algebra 2, graph equations of lines. So our objective is to know the difference between standard form and a slope-intercept form and how to graph each form. First thing let's do is let's review some stuff from previous chapters, the previous sections here. So given those 4 points, what's the domain and what's the range? Remember your domain, that's all your inputs, your x values. So my domains are all of those numbers. So I want to list those out. 1, 2, 4, and 6. Listing those in order. Now I want to look at our range, and our range, that's our y's. And remember, even though we have these two numbers that are repeated, the 3's, we don't list it twice, just list it once, 3, 5, and 9. Now, is this function, or is this a function, y or y not? Well, all we have to do is we have to look at any of our x's, our inputs. We don't have any repeated inputs, so we don't have to worry about it. But if we had any repeated inputs with a different output, it wouldn't be. So yes, it is, and we just talked about it, because there is no input with multiple outputs. All right, finding the slope. Remember the slope. Our slope is m equals y2 minus y1 over x2 minus x1. So for those ones, x1, y1, x2, y2. So m is going to equal 5 minus negative 3 over 4 minus 2, which is going to equal 8 over 2, which equals 4. I'm not going to do the second example. If you guys want to do that one, feel free to do that with some extra work. All right, let's talk about graphing. This is the heart of what we're going to do today. So first thing I'm going to do is I'm going to graph with using a table. And using a table, I'm going to pick the x's I put in. It's going to change, and then I'm going to find my y's after that. So I always start with negative 2, negative 1, 0, 1, and 2. Now I'm going to plug in my points here. So negative 2 in for x. Negative 2 times 2 is negative 4, minus 4 is negative 8. Do the same thing with negative 1. Negative 1 times 2 is negative 2, minus 4 is negative 6. 0 times 2 is 0, minus 4 is negative 4. 1 times 2 is 2, minus 4 is negative 2. 2 times 2 is 4, minus 4 is 0. Now we go over to our graph, and remember our x's. Here's our x-axis, and here's our y-axis. X's go left and right, y's go up or down. So since it's negative 2, we're going to go left 2. Negative 8 for my y, we're going to go down 8. So we're going to get the point down here, negative 2, negative 8. Then we're going to go negative 1, left 1, down 6. 1, 2, 3, 4, 5, 6, yep. And 0, negative 4, down 4. 1, negative 2. And 2, right 2, not going up or down at all. Now all we have to do is connect our points here. Draw the arrow saying that it's going to go on. All right, I'm not going to do that last example. You guys can do that one if you like, because I'm going to show you guys some quicker ways of doing this than graphing tables. The first way is if I have in slope-intercept form. Remember, slope-intercept, what that is, it's y equals mx plus b. Now there's a couple things we need to make sure we know with that equation. First thing is what the m means. What is that? Well, that's our slope. And remember, slope is rise over run, which is really our change in x over our change in y. All right, and last thing we need to make sure we know is that b, what that is, that's our y-intercept. And remember, what y-intercept means, that means the point that is on our y-axis. So let's go down and let's graph some things knowing this. I want to look at y equals x minus 1. Well, first thing I'm going to do is I'm going to look at the slope. Well, if you notice, there's nothing in front of that. But we know that if there's nothing in front of the x, really there's a 1 there that we just don't write. And for my y-intercept, it's going to be at negative 1. So I'm going to go graph. First thing I'm going to graph is my y-intercept, because that's easy to graph because it's right on my y-axis. So down here on my go to negative 1 on my y-axis. And remember, y is up or down. So we're going to go down 1. Now my slope is 1. That means that my rise over run equals 1. So it must be 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. We could also go down negative 1, left negative 1, because negative 1 over negative 1 is negative 1. Now I have enough points there where all I have to do is just connect my dots and keep it going through. And there's our graph. Easy peasy, right? Let's look at this next one over there. Again, I'm going to look at my slope. Here's my slope. That's my rise over my run. And we have our y-intercept. Our y-intercept's at -2, so I'm going to go down -2 on my y-axis. And now again, slope is rise over run, so we have 3/4. That means I'm going to go up 3, 1, 2, 3, and I'm going to go over 4, 1, 2, 3, 4. And there's going to be my next point. Again, this is a positive 3, 4, so I could go -3, 1, 2, 3, and I could go left 4, both being negative, and draw a point there as well. I want at least 3 points to make it so it's actually a valid graph. You guys can see that when you're using the slope-intercept form, and you just draw your line going through there. Sorry if my line's not perfectly straight. I'm a math teacher, not an artist. All right, I want you guys to try these last 2 problems. You should be able to get some graph paper offline there. I also have some on Schoology if you guys are using the Schoology site. Print that off and try it, and I'll show you my answer. All right, here's what my graphs look like. Now I know what you guys are asking is, do I have to, let's see, let's get a highlighter here for you. Do I have to do these pieces here where I'm actually showing the steps? The answer is no. I don't need to actually see those, and I'm sure there's not many teachers out there that do. I'm showing you guys those to show how I'm doing it. If you guys can do that in your head or just counting up, go ahead and do that. You don't actually have to show those pieces. I was showing those just to show how I did it. All right, the next thing we have to look at is standard form. And remember, standard form looks like this: ax plus by equals c, where we have whole numbers. Now this one can get a little bit tricky, but really what I'm going to look for is I'm going to look for the x-intercept and the y-intercept. So when I'm in standard form, all I need is just 2 points, and those are the x-intercept and the y-intercept. There's some things that we need to make sure we know about the x-intercept and the y-intercept. When we're on the x-intercept, always, no matter where we are, we don't go up or down at all, right? So our y is always going to equal 0. And when we're on the y-intercept, our x is going to equal 0. So in order to graph these, what I like to do is I like to make a table. So let me show you guys an example here. So I'm going to make a table here. I'm going to make an x and a y. And what I'm going to do is I'm going to plug in, well, I'm going to make, to find my x-intercept, I'm going to make y equals 0. And to find my y-intercept, I'm going to make my x equal 0. So again, this is to find my x-intercept, and this one right here is to find my y-intercept. And now what we have to do is we have to plug those into the equation. So to plug in the y equals 0, I'm going to plug -2x minus 3 times 0 equals 6. Some of you guys always realize that that equals 0 minus 0 equals 6. So -2x is going to equal 6. Now some of you people can switch right to this point to -2x equals 6. That's fine because you know that 0 is going to cancel out the y. So now we just solve from there, divide by -2, so x equals -3. And that's going to be our x value. Our x-intercept is going to be -3, 0. We're going to do the same exact thing for the y-intercept, and we're going to do, instead of when y equals 0, we're going to make when x equals 0, minus 3y equals 6. Again, you can see that 0 minus 3y equals 6, so -3y equals 6. Again, this point right here is something some of you can skip to. If you can skip to that point, do it. That's fine. Last thing we need to do is divide by -3, so y equals -2. So 0, -2. Now all I have to do is go plot those points. So again, my x is -3, 0, so I'm going to go left 3, 1, 2, 3, and not go up or down because my y is 0. My second part is 0, -2, so I'm going to not go left or right. I'm just going to go down 2. Now I have 2 points that I connect to make my graph. Now there's only 2 points needed for this way for graphing in standard form. I'm going to let you guys try this one on your own, so please pause, try it on your own. So here's what I got, and I color-coded it for you guys so you guys can check my work and see what you did wrong if you did something wrong. Otherwise, if you did perfectly, then awesome. All right. Second to last thing we're going to talk about are vertical and horizontal lines. What you need to know is when I have an x equals something, anything, that number or that line is going to be a vertical line going up and down. When I have a y equals something, just a number, a constant, we're going to have a horizontal line. So I'm going to show you guys how that works, and I'm going to show you a couple of examples, and I'm going to have you check the other ones if you'd like to on your own. So x equals 3. Well, we just know from what I said that that means it's going to be a vertical line. Well, really what we can do is we can go, okay, well, when y equals 0, so down on the x-axis, we know that x is going to equal 3. We also know that no matter where we go in the y, x is going to equal 3, and you guys can see as we're going up that this is going to make a vertical line. So our x equals 3 is going to be a vertical line. Well, now let's try the y equals -1. And again, we can look right here, wherever our x is, our x value, y is always going to equal -1. It doesn't matter. So you can see that those start to make a horizontal line. And it's always going to be that way. When x equals 0, well, if we do x equals 0 when y equals 0, it also equals 0 when y equals 2. Doesn't matter. If you can look on that, we're on the y-axis, a vertical line on the y-axis. Now I threw you guys a little screwball here. We have f of x equals 5. Now that's the same thing as saying that y equals 5. It's just using function notation. So it is, again, it's a horizontal line. We go up to 5, 2, 3, 4, 5. And no matter where we go on that, our y is always going to equal 5 because there's no place to put in the x on that f of x function. All right, that's all we're going to do for section 2.3. So go ahead and rewatch anything you need, do the problems, and let me know if you have any questions.